Stored procedures are primarily used by DBMS to break more complex tasks into smaller, more manageable steps. Unlike the standard programming language procedures, these are managed by the DBMS, which takes care of such things as recompiling the procedures when needed because of either change in the procedure itself or the underlying SQL statement. As was mentioned before, stored procedures reside and are processed on the server rather than the client, which significantly speeds up some of the processing. They also allow for more complex application logic building and contribute significantly to improved database security. All the banks use the stored procedures for you to interact with your accounts. You're never anywhere close to interacting directly with the database tier where your actual account data resides. The next three slides provide several examples of simple stored procedures and functions, including the use of cursors for processing of record sets that result from select statement operations. The first two examples demonstrate the use of stored procedures that retrieve a single row of information, which is where the into statement comes in handy. The first one uses the modified version of the if-then-else statement for determining employee status and is located in MySQL 4_38 stored proc and retrieve.sql file. The second one is used to display product information with multiple output variables, uses the case when statement developed in an early example, and is located in MySQL 4_39 stored proc in out retrieve file. The third example from this slide is used to insert a new customer order and, among other things, demonstrates how to call one stored procedure from another. The code for you to complete is located in the MySQL 4_40 stored proc insert into SQL file. So all three of these files I'm going to open up right now are shown right here. Okay, 38, 39, and 40. So we'll start with determining employee status based on the employee ID passed to this procedure, as well as the cutoff date for determining whether an employee is new or seasoned. Okay, some of the variables that were declared include low and high salary from the previous example. Those are the salary cutoff slash brackets. Employee status, that's going to compile all the information into a one large string, as well as some of the sort of intermediate variables that will hold for the selected employee ID, for the given employee ID, his or her first, last name, hire date, rank, and salary. The first thing we do after the declaration is we run a select statement, okay, retrieving first name. These are the column names from the employee table, last name, hire date, rank, and salary. So the 5 pieces of information, and we insert them into EMP first, EMP last, EMP rank, hire date, EMP rank, and then EMP salary, right? So this tells you already that this kind of a construct can accommodate only one single row, right? This comes from, again, employee table, where employee ID is EMP ID passed to this procedure through this input parameter. Okay, so more than, if this select statement would result into more than one row, which it won't, this into statement would not simply work. It's also possible that the employee ID does not exist, although for this example we'll assume that it does, and we'll deal with what if that's not the case in another example. Okay, then after that, the status variable is set to the employee first and last name, aka the full name. We're going to use the if statement to determine, just like we did in the previous example, if the hire date is after the cutoff, then it's a new employee, otherwise it's seasoned, and that concatenates his or her full name. The rank is based on this information, and it's going to be either sales or sales manager, just like it was in the previous example, and the brackets divide these employees into low, medium, and high salary, and then the employee status is returned. Okay, so we're going to copy first the procedure. Will go into Toad and see if it compiles. Okay, and then after that we'll switch back and we'll discuss the call, which is going to use an existing employee number 51 and that same cutoff date of January 31st, 2020. Okay, to determine that Inez Hudson, which is employee number 51, as you can see by opening employee table, data tab, and going down to 51. So she is a seasoned employee with a rank of sales clerk having a low salary, right? So she's a seasoned employee because she was hired before January 31st, 2020. Okay, she is a clerk. You can see all that information again in the employee table, row 51. Okay, she's a clerk hired in 2010, so way before 2020, and has a very low salary, as you can kind of tell. So you can test this with different employees, different dates, and so forth. Okay, I'm going to close that, switch back to the code, save and close the file 38 and switch to file 39. Okay, in this example, the store procedure summarizes the product groups. Okay, it has again one input variable, product ID, just like the employee ID was the input for the previous procedure, and in this case it shows how to use 1, 2, 3, 4 output variables for product name, price, and inventory that will simply look up based on the product ID, and then shipping time, which is going to be based on the case select or case when statement. We declare the product group as a temporary varchar variable, and then we write the SQL statement that will select prod name. So prod name is the column in the product table. Prod group, retail price, and on hand. Okay, those are the 4 pieces of information that correspond to into product name, product group, product price, prod price, and prod inventory. Although it does not matter. Okay, well, we'll try to name these variables that we are inserting into something, something other than something different from the actual column names, just to be on the safe side. It comes from product table, where product ID is prod ID, the parameter passed to this procedure. Okay, then based on the product group that was retrieved right here from the product group column of the product table, we're going to have the same case when statement that we had in the previous example, right? And we're going to get our shipping time, right? So we're going to use an existing product we know exists, 138. We're going to retrieve the name, price, inventory, and then we're going to return the shipping time based on the product group that it falls into. So first, let me see if the procedure compiles, which it should. Then we're going to go into the tables and look at the product table number 138. Right here, hockey stick. All right, the retail price $27.99, and the number of hockey sticks on inventory 96. Hockey gear is the group, which means shipping within 3 to 9 business days. Okay, so now I'm going to make a call to this procedure, with one input variable, right? Okay, which is the product ID 138, and 4 output variable, name, price, retail price, inventory, and time, and we're going to then display those guys. Hockey stick $27.99, 96 within 3 to 9 business days, matches what we just saw in the table. Okay, clear that, go back to the code, save and close procedure number 39 on this display product info, and continue with modification query, right, where we're going to actually insert a customer order into this database. We're going to need 2 procedures for it. One is the insert custom order that deals with the order table, order TBO, and then insert order detail that works with that particular one. Okay, so what we're going to do first, we're going to create the insert custom order procedure. The input parameters required are all the columns of the Well, not all the columns, but all the necessary required columns of the customer table, which obviously of the order table, which are order ID as integer. Okay, then another input parameter is cust ID, which is also integer. EMP ID, that one's technically not required because it could be an online order, but we'll assume that it is just for simplicity. And then order date, ORD date as date is required. Okay, now if you save this temporarily, go back and look at the orders table, not order table. Okay, we're going to see all three of those, right? So then we're going to switch back to the code, and we're going to somehow lost the begin statement. I'm going to put the begin statement, and then we'll start with insert into orders table. We have order ID, customer ID, employee ID, and then order date. Okay, and the values are going to be coming from these variables: ORD ID, cust ID, EMP ID, and ORD date. Okay, and then the semicolon. Oops, semicolon right there. All right, so it's a single statement procedure, so we could skip the begin and end, but I tend to keep those guys in just in case. It is not enough to just insert into the order table. We also have to insert at least one order detail. In this case, I want to have two. So what I'll have is, first of all, review the fact that you need the order ID, product ID, and product quantity variables to come in, and then insert into order detail order ID, product ID, quantity. Okay, and then the values are coming from these variables: ORD ID, prod ID, and prod QTY. Make sure you have the semicolon. Okay, the testing procedure that's going to demonstrate this insertion, right, is also showing how to call other procedures, right? Specifically, we're going to call customer order with an order number. We know it's not taken 3,000 existing employee, a customer rather 406 existing employee 97, and some random date in 2025, and then knowing that we have these hockey sticks 138 and I think hockey something else, I forgot what it was, 139 is hockey uniform here, two quantities of sticks and one of the uniform. Maybe we're going to have some counts before and after to see that sort of the insertions were made. So we're going to copy these guys one by one to see if they compile, starting with the insert cust order. Go here, we're going to close some of this stuff. Okay, that compiles. Remove it, copy the insert into order detail, paste, see if it compiles, and then I'm going to see all those guys should be here if I refresh. Insert custom insert order detail, and then the testing procedure that's going to call these guys in order that was just described. Okay, so let's see how that results. Okay, so that one compiles as well, testing, adding customers, and then we have to run it. Okay, so it shows the last, the grid shows the last of these guys, unfortunately. So we would have to figure out a way how to sort of output this into a table, which is sort of too much for us. So we're going to have to check this sort of manually. So go to the tables, orders table, and it should be at the bottom. Okay, it has more than 1,000 records, so you have to unfortunately do some work twice, right? So that's a 3,000 for 697. Christmas Day 2025, and the details, okay, the details are these two guys here, 138, 139 for quantity of 2 and 1. Okay, close that, close that. and make sure it's saved and closed. So I'm going to switch back to the presentation, and this is a good place to pause.